Hi, this is Alex from devstories.eu. OpenCV Computer Vision Deep Dive, Episode 10 of 20. Traditional object detectors suffer from a severe form of tunnel vision. They can perfectly track cars, people, and bicycles, but ask them to find a spilled coffee cup and they are completely blind, limited to the handful of classes they were explicitly trained on in the lab. To fix this, you do not need to label thousands of spilled cups. You need YOLO-World and Open Vocabulary zero-shot detection. Consider a specific scenario. You run a retail store security system. You need to search live video feeds for a blue Hydro Flask bottle or a lost golden retriever. With a standard fixed vocabulary detector, you would have to halt the system, collect images of golden retrievers in your store, manually draw boxes around them, retrain the model, and redeploy. With YOLO-World, you just type the text prompt into the system. It finds the object instantly, zero shot. This is not a text-to-image generative model. It does not create pictures. It is also vastly different from merely adding a new class to an existing dataset. Open vocabulary detection relies on a deep semantic understanding of language. It directly maps linguistic text prompts to visual bounding boxes. The system takes two inputs, an image and a set of text prompts. It uses a vision backbone to extract visual features from the image. Simultaneously, it uses a text encoder to translate your text prompts into mathematical vectors, called embeddings. This is where it gets interesting. These two distinct streams of data must be combined. YOLO-World handles this using a structure called rep-VL-PAN. That stands for Reparametrizable Vision Language Path Aggregation Network. The acronym is dense, but the function is straightforward. Rep-VL-PAN fuses the image and text features. It injects the semantic meaning of your text prompt directly into the visual feature map at multiple scales. As the network processes the pixels, it is actively guided by the text embedding. The model learns to do this during its initial training phase through a mechanism called region text contrastive loss. The model generates bounding boxes and extracts visual features from those regions. It then compares those visual features to the text embeddings. The contrastive loss penalizes the model heavily if the visual features of a box do not align with the correct text embedding. It rewards the model when they match. This forces the network to align its visual representation precisely with linguistic concepts across massive datasets of image-text pairs. It learns what blue, Hydro Flask, and bottle mean as general concepts, rather than memorizing a single rigid category. When you run the model in production, the workflow is incredibly clean. First, you define a custom vocabulary list containing your target objects. You pass that list through the text encoder once to generate your text embeddings. Then you feed your live video frames into the visual backbone. The rep-VL-PAN architecture fuses the incoming visual data with your pre-computed text embeddings. Finally, the model returns bounding boxes and confidence scores based on how closely the visual regions match your words. The real power of YOLO-World is decoupling the detector from a rigid dataset, allowing you to use natural language as a real-time executable query for the physical world. Thanks for tuning in. Until next time.